Welcome back to part 3 of this MonstAR tutorial, and well, this is the final part. In the last part, we made the plane spawn in, and we also actually made the buildings appear, and yes. So what we're going to do now? Well, we're just gonna make the planes crash as you tap them and explode with some particles and yeah, just that little effects. And we're going to add some scores. Okay, so let's start with the plane crashing. So here in last part we actually did this common plane crashing stuff later in part 3, but here, so this is part 3, so I can just get rid of that. And let's start with guard let, and we're going to do a hit test for the nodes. Now that we have to type scene view dot hit test, and it's this one, hit test, with this dictionary here, SCN hit test option, and this searches this a hit test for a point in an image. What the point in the scene, or from the screen. Now this is like having the tracker node. So like this is a point we're going to do, and then this is any options. If an else return but first we need to get the the location of our touch. So now we need to get guard let touch equals to touches dot first. So getting the first touch, and then if you can't find that, just get out and return. So then now we have to get the touch location. So the touch location equals to touch dot location in UI view, then we're just gonna leave the view. Now, well, that gets a CG point, so we can just slap that in, touch location, and then we don't need any options. But it's like options if you want to do like hide, like ignore the hidden objects, and so on. And now we're gonna get the first one, because it can actually, because here's like one plane, and then if it actually touches this, but what if there's another plane back, it actually gets this and this, so it returns an array of them, but we just need to get the closest one. Makes sense, right? Because the user looks at the closest one and just goes bye plane, and then once it's found that, we can get the node from that. So hit node, so let hit node equals to node hit node, what is that? Node hit test, and then we can get the hit node from the node hit test dot node. So it's going, so this returns like SCN like hit test result, and then here so what we're going to do is we're going to check if the node that's been hit is a plane. So guard hit node is dot name is equal to plane, and because up here this is actually already named, like it's copied, and it's copied from well, I guess it's copied from the original plane, and the plane's being named plane, so it copies the name. So yeah, and then else the return. There we go. Okay, so after we've known that the plane's been hit, now we can set the hit node dot physics body, because we want the plane to fall. So hit node dot physics body dot is affected by gravity equals to true, and then now we can and after that it will just fall. But we also needed to do some spinning, like it like rolling about and then just tipping down. So what we're going to do is we're going to create a constant for the force that hit the plane spin force, and that's going to be an scene vector 4 make. Now scene vector 4 is, well, x, y, z, and w. Now what's a w? We're not in the fourth dimension. Well, what it does is that it actually does, for the x spinning, so pitch, it's going to do x times w, and that's the result. So and then y is the yaw, so it's y times w and z times w for the z. Because if you see here, we can do 0.5 and 1.0, and then this is meant to be how much you want to turn. So like, let's say 50, which is actually a lot, crazy a lot. So that means it goes 0.5 times 50. Now that's going to be the pitch. So that's going to be 25 here for a pitch. 0 times 50 is 0. So that means it doesn't spin here. Then 1 times 50 is, well, 50. So it'll do 50 force for a roll. So yeah, so that's what it is. But what I want is, we just want 0.5 for pitch, so it can go down. So 0.5 times 1 is, so it's actually partially tipping down. It's not going left or right at all, and it's spinning full throttle by 1. Yeah, so it actually gets a full rotation stuff. Okay, now we can do hit node dot physicsbuddy dot apply torque, and then that's going to be for plane spin force as an impulse. Well, yeah. And then, oh, now let's just check if this will explode, and yeah. So command R and run. Okay, game is up and running, and let's find a good spot. Yeah, there we go. Oh geez, that's a bit hard, but anyway. Now let's try to there we go, it actually spins. So what we have left is the particles and the score. Let's see if I can get another one. Okay, so well, let's do the score first. So we're going to do a score UI label. So var score label, and that's going to be it. So UI label, there we go. And then we also need to keep track of score. So we have an integer. So var score is equals 0. And then this is going to be quite smart. So here I have curly braces after this. You might be asking, why? Why is that? Well, I can do did set, and that's going to make it so this is an observing a property observer, and what it does is it checks if its value is going to be set, and there's will set and there's did set. Now did set is after it's been set, will set before it's been set, you know. And so if it's been set, we can update the score label, so we don't have to do it down there. It keeps the code clean. So if it's been set, then we set the score label dot text to be, well, the score, so score. And then now what we can do is, here, once the game started, we can put in the game. So now let's put the score label here. So it's score label dot equals to UI label, and that's going to be a frame with CG rect. Now CG rect That's CG rect. Very good. And here we go. So we want it to be 0. Y is going to be view.frame.height, and that is going to be times 0.05. So there's a bit of margin, and then the width will cover the whole of the view's width. So it just stretches across, and then the height will be view.frame.height times 0.1, so a tenth of the view's height. So now we can do the score labels alignment, text alignment, to be in the center. And then now we should also make it bigger, because as default it's quite small. It's about like this text big. Like, no, I'm saying like it's basically like the font you see here. So score label dot font will be UI font. There we go. And let's do Arial. And then here the size is CG float. So let's do view.frame.width. So 10th of the width. So view.frame.width. The reason why I do times is you can do divide, but it's quicker to do multiplication. Computers are faster doing multiplication than doing division. So that's why I'm multiplying it by a fraction of 1, so like a decimal. And then now we can set the score labels. Let's do a text color, and that's going to be yellow. Nice big yellow. And then we do score label. We should set the text now, so score label.text is equal to 0, or you can do score with the score interpolation. Yes, either way it'll be 0. And then now we can do view dot add subview score label. Very good. So we've added score. But then down here we need it. It's no point having a score label if you just tap a plane, because you only get a point when you get tap a plane. But what's the use of it just being 0 even if you tap a plane? Like 0, 0, 0. That's just gonna be unfair. So here, when we hit a plane, here we're just gonna increment the score by 1. Very good. So let's run it. And then once we've done the score, and you're just testing it. Once the score is done, we can do the final thing. Explosions. Here we go. So we have the score label. It's up there, and once we click it, we get 1 point. So yeah, let's see if it goes up to 2 when I click another one. Yep. So let's just finish this off, finish this game off with a bit of explosions. Who likes some explosions? Okay, so final thing, explosions. So just go up here and go to File, New File, or Command N, and very good. So make sure you have iOS up. I'm pretty sure you guys will. So you just scroll all the way down, and when you see this SceneKit particle system file, just select that, and you're ready to click next. You're going to do fire, because it's more like an explosion. So let's go here and just name this explosion. Simple. And then now we can create this file. Very good. So you can see here that once you created the particle system, it automatically creates a spark like image, and that's just for the little particles here to make that shape. And here. So let me explain to you what all this stuff does. So this is a birth rate. So that's how fast it goes. So for more it is, for more particles you'll see. And this on the right, if you see the triangle equals and that here, that's called delta. So it's basically like having a range. So it's so let's say I put up 10. Okay, so then the minimum birth rate would be 509.6 minus 10 to 509.6 plus 10. So I'll leave this at 0. Then this is a warm-up duration, and if you noticed, if you go out to another file and then come back in, the fire will start again and it'll start up the smoke. And if you do this, it'll go like, this is like 50 seconds before it actually, it warms up 50 seconds before. And this is if you want it to just happen instantaneously. So that's warm up duration, and this is a location. So it's better for me to just demonstrate this if I put this in a box. So yeah, so the shape is just making it the particle in a shaped like box. So this is surface, so it will spawn around its surface. This is the volume, so it will spawn inside the box, and then vertex is the edges of the box. I don't know why it doesn't do these two edges, points here, right there. But anyway, so emission space. Let's put this back to surface. This back to, let's put in point. And road space means that when you move it around, but you can't really see it in this preview, it would leave, in road space, it would leave a trail behind. For local space, it would just it'll keep in a straight line. It won't leave a trail behind, but just always go up. So we're gonna do world space and direction mode, surface normal. Wait, let me go back to box. Yeah, so it goes like the directions of the surface. So if it's on the bottom, it'll go down. On the sides, it'll go sideways, up. And then if it's on the top, then it'll just go straight up. So constant is just one specific direction, and random, well, they'll just go randomly. So let's put this back to point and direction mode. Yeah, you can do random. And then simulation is, so this is like the lifespan. So if I do 5, it'll live much longer, as you can see here. So yeah, that's the lifespan, and this is like the velocity, the speed. 2, much faster. 4, yep, even faster. So yeah, that's velocity. Angular velocity, so if it spins around like crazy, and this is acceleration. So it'll just, so this currently it's going upwards. So if I do -1, it'll go downwards. So 0 just relaxes like it's in space. 10. So yeah. So that's what acceleration is. Speed factor, how quick it is, of course, and stretch factor. So 1, it'll just stretch it apart. And this is an image and the color. So you can animate it. So yeah, I can make it a disco if I want to. Not sure why you want to, but this looks, yeah, this is nice. And this is size. You can make it bigger if you want to. Yep, much bigger. And then intensity is how intense these colors are. And then you can have an animation of colors. And this is how you animate the little particles. So they go dancey, like you can make a puff of smoke, like a little animation like that. But sorry, we're not gonna animate it today. But sure, you can do it on your own in your own app. You need a sprite sheet, and service rendering is how it renders the particles. So yeah, this is a blending mode. This is billboard. So the orientation. So it will always be facing us. Because the particles, if you see, they're actually just they're just 2D and flat, like a plane. But when you put it to 3, it seems like it disappears. So you leave it in screen aligned billboard, and this is how it's sort of. Oh yes, and you can make it adjusted with like lighting, so there's a darker part and lighter part, but nope, we're not going to do that. And this is particles, like if you want it to be affected by gravity, mass, friction, bounce. That's it. That's the stuff. And this is the emission duration, so you can loop it or just play it once. So like you could have so if you do continuously, you could have 2 seconds of emission, and then after that, it'll go to idle for just 1 second. So that's what it is. Just gonna keep it in like that. So you're gonna do. So what I want you to do is just make your own explosion. I'm gonna go make mine now. So I'll be there in a second. So yeah. So let's just make it. Okay, I created my own explosion. Let's continue on with the explosion. It doesn't need to be explosion for you. Like, no, you don't need to have like a good explosion. We're meant to come here for this augmented reality tutorials, so I can teach you more about a bit like SceneKit and ARKit. Also mostly targeted for ARKit. So now let's create an explosion. So lit explosion. So creating an explosion here equals to SCN particle system. And adding a particle system is quite easy. Just need your own explosion, your own particle, and then 2 lines of code. That's all. And so yeah, this is a sim particle system, and so we need to get the name of this explosion particle file. So that's going to be explosion with a capital S .scnp, and then if it's in any other directory in any other file, but that's not in any other file, and that's force unwrap it because this would return an optional. Because what if someone made a typo? And anyway, so if you want, well, we're not gonna do this, but you can actually do all that stuff that was in the sidebar when you open the explosion file, but you can do that programmatically. But we did that in the SCNP file, so let's head on and just put it on the hit node or the plane. So hit node dot add particle system and put an explosion. So well, that's all we need for particles. So let's test this right away. Okay, so we have the game up and it's launched. So there we go, and we place it, and here is the planes coming in. We try to, oh yeah, there's the explosion. So we've done it, guys. Yeah, we've practically done it. So let me, yeah, so planes are falling. They're falling. Yeah, they are falling. So that is a game. Finished it. The game is finished. So well, that was really fun. You can go and play yourselves, play with the game yourselves, and my high score is 400, but there's no time limit. Well, yeah, so it took me some time, but eventually I got there. So, well, that's it. So, see you in the outro. That's it. I hope you enjoyed this video and you learned something new about ARKit. And again, you can get my new and latest ARKit app, Let's Stack AR, at my website www.madebyuma.com, and goodbye!